You may use a calculator on your test. So this first group of questions is really just use a calculator to calculate the permutation and combination values. So if that's something that you don't know, that is something that you should figure out and ask me before your test, and really before Friday, because I won't be here on Friday. So today or tomorrow we need to work out how to use your calculator. You can't use a cell phone calculator on the test, so if you need to borrow one, that's fine. But you need to make sure that you know how to use it to calculate these values. So whatever type of calculator you're using, you're going to want to go into your probability menu to calculate 4P2. And I'll just put the answers up here, but it's your responsibility to make sure that you know how to get these answers on your calculator, since every calculator is a little bit different. So the first two have a P in them. The second two have a C in them, but they're dealing with the same numbers. What is the difference between the P and the C? What do those mean?
The C is the combination.
C is combination, and P is permutation. And what do those mean? What's different about a combination and a permutation? When do we use one versus the other one? In a combination, the order of selection does not matter. So in a permutation, we're picking things to place in a specific order. So AB is different than BA. Whereas in a combination, we're just picking things and we don't care what order. Same thing. So if you're working with the same numbers, a combination should always be smaller. So we would expect these two combination values to be smaller, and that 9C7 is much smaller than the permutation. Okay. In a permutation, the order matters, so AB is different than BA. In a combination, the order does not matter. So those have smaller options. To find the number of ways that we can rearrange the letters in a word, we take the number of letters in that word factorial. 6 letters in the word Dallas. So we take that factorial and divide by any letter that repeats, how many times it repeats. So D does not repeat. A repeats twice, so 2 factorial. L repeats twice, so 2 factorial. S does not repeat. When you calculate this, calculate the top and the bottom separately and then do your division. That factorial exclamation point is in the same place in your calculator as the NPR and the NCR should be. So calculate the top and the bottom individually and then so that means there are 180 different ways that I could rearrange the letters of the word Dallas and tell a difference. So if I put each of those letters on a note card, if all I did was swap the 2 A's, you wouldn't be able to tell the difference. Or if I just swapped the 2 L's, you wouldn't be able to tell the difference. So we're not counting those. But in terms of actually being able to see a difference, there are 180 different ways to do that. Questions? Next type of problem is our card problems. If you are still uncomfortable with a deck of cards, I will have the same cheat sheet that you had in your notes available to you. It won't actually just be printed right on the test, but I'll have a stack of them there, and you can feel free to ask for one of those during the test if you need it. But it doesn't have colors, so you still need to know what kind of cards are red and what kind of cards are black. But otherwise, it can help you with the other stuff. So how many of the cards in the deck are red? 26. All of the hearts and all the diamonds are red, and there are 52 cards in the deck. So 1/2 chance of drawing a red card then. You can give your answers as decimals or as reduced fractions. A red ace, how many of those are there? 2. There's the ace of hearts and the ace of diamonds that are red. So that reduces to 1 out of 26. A spade, how many spades are there? 13 out of 52, which reduces to 1 out of 4. A spade is one of the 4 suits. Queen of diamonds, how many of those are there? There is just 1 queen of diamonds. A jack, how many jacks are there? 4 out of 52, which reduces to 1 out of 13. It's one of the 13 types of cards. Questions on that? Yes.
Is it okay to get it as a percentage?
Yes. Percents or decimals or reduced fractions are all okay. And number 11, what does that notation mean? We read it as prime. And what does it mean for probability? We do 1 minus it. The word starts with a C.
Isn't it the complement?
The complement. It is the complement, and that means the probability that something's not going to happen. So this says there's a 3/5 chance that whatever A is, it's going to happen. So when we're asked with the prime or the complement, what is the chance that it's not going to happen? And we find that by doing 1 minus the probability given, which would be 2/5. So you need to know that that notation means complement, which is where we do 1 minus the given probability. The next 2 questions I would do as Venn diagrams. They don't have to be done as Venn diagrams. There were formulas given in the notes if you're more of a formula person, but I'm more of a picture person, so I like Venn diagrams. The probability of A is 30%. The probability of B is 70%. A or B is 100. What does or mean? When we add it up, what it equals. So if we add up everything, it should be 100. What do we get if we add up just A and B? 100. What does that mean? There's 0 in the overlap. So A could happen at 30, B could happen at 70, but A and B cannot both happen. There's nothing in that overlap, so the and would be a 0% chance. There's no way that A and B are both going to happen. For the next one, A is 0.5, B is unknown. Or is what we get when we add, and we get 0.6. And what do we do with the and? Put it in the overlap. So we have 0.2 in the overlap. What does that mean about the probability of just A?
You have to minus.
So we subtract out the middle. So just A is 0.3. And if it's supposed to all add up to 0.6, what does that mean about just B? 0.1. And all of B then is 0.3. The entire B circle is what we want for the answer there, not just the B portion, but the entire B circle. Questions? A and B are independent events. That means whether or not A happens has no effect on whether or not B is going to happen. A has a 0.4 chance. B has a 0.6 chance. A and B, what do we do for and?
You add them.
Multiply for and. So I'm going to multiply those together. So the chance that A and B both occur is 0.24. The next problem tells us that B and A are dependent events. So if A happens or doesn't happen, it can affect whether or not B will happen. We don't know the chance that A will happen. And then we have this notation here. That means the probability that B will happen, assuming that A has already happened. Okay, so we did this yesterday in our card problems when we said without replacement, for that second draw, we would assume that we did get what we were going for. So that's what that notation means when it has that line in there, is the probability that B is going to happen, assuming A has already happened. And them together, we get 0.56. And means what? Multiply. So that means whatever A is times 0.7 should be 0.56. So what is A? 0.8. So the two problems are worked in the same way, that they're both multiplication questions. It's just really our notation that changes when we think about the difference between independent and dependent events. Suppose you play the 3-digit number 123 in your state's lottery. If we are playing the 3-digit number 123 in our lottery, how many tickets did we buy? So if I'm playing the number 123 in the lottery, how many tickets did I buy? How many? Just one number. 123 is all on one ticket. So this is a 3-digit lottery. I'm playing one ticket in the lottery. My lucky number was 123, so I bought one ticket that had 123 on it, and I'm going to hope that's the winner. The question is, what is the probability that that is the winner? So we need to know how many different possible tickets there are. It says that digits can be repeated, and there are 3 digits. So how many different numbers could be the first digit of the winning ticket? 10, because 0 is a digit. So there's 10 different numbers that could be that first digit in the winning number. Whatever the winning number is, there's 10 different things that could be that first number, because 0 is a digit. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 could all be a possibility for that first number. What about the second number? So big key here is assume digits can be repeated. So how many numbers could be the second number? 10. And how many numbers could be the third number? 10. And we know there's 3 numbers on the ticket because we're playing the number 1, 2, 3. Okay. So we get a 1 out of 1,000 chance of winning that lottery. Find the number of possible batting orders for the 9 girls on the softball team. Does order matter here? Is it different if you bat first or if you bat sixth? So if you play softball or baseball, you know that batting orders are actually a pretty big deal. Okay? Or if you like to watch sports, you know they're a big deal. That batting kind of in the 1, 2, 3 positions or the 4 position are a big deal. They usually get more at bats and for people getting on base. So batting order is a big deal, and order is something that matters here. So does that mean that we're going to use permutation or combination? Permutation is when order matters. How many girls am I picking from? 9. And how many of them am I putting in the order? All 9 of them have to bat at some point. The first number is the number that we're choosing from. The second number is the number that we are actually choosing. And we did a permutation on this problem because the order we pick the girls matters. If we were doing a problem in which order would not matter, so we're being selected just to be in a group, and it doesn't matter whether you're picked first or picked last to be in that group, then we would do a combination. Questions? Last problem, you're playing a game that involves first drawing a card and then rolling a die. What is the probability that given you draw a black, you're going to roll a multiple of 2? We need both of these things to happen to be successful here. So first, what is the probability that we draw a black? How many black cards are there? 26 out of 52. And then I need to roll a multiple of 2. How many multiples of 2 are there? There are 3. 2 out of the 6 sides on the die. These both reduce to a half to give me a 1/4 chance of that occurring. Multiples of 2 are 2, 4, and 6, so there's 3 multiples of 2 on a die.